In the last experiment, you standardized an NaOH solution. In this experiment, you will use that standardized NaOH solution to titrate an unknown acid. You will be given an unknown mixture that contains some KHP and other non-reactive chemicals. You will use your titration to determine exactly how much KHP is in your sample. The procedure asks you to prepare your unknown solution in a 100 milliliter volumetric flask like this one. Like a volumetric pipette, this volumetric flask is calibrated to 2 decimal places of accuracy so long as you fill the liquid up to the mark that is shown on the neck of the flask. Use a funnel and a spray bottle to quantitatively transfer all of the unknown into the volumetric flask. Now you can fill the volumetric flask to just below the calibration line.
Using a transfer pipette, carefully filter the line in the volumetric flask. Make sure all the KHP is dissolved by inverting the flask several times. Using a volumetric pipette, transfer 25 milliliters each of the KHP solutions into the 2 Erlenmeyer flasks. Also add about 80 milliliters of water to each flask and then a few drops of phenolphthalein indicator. Now you carry out your titrations exactly as you did in the previous experiment.
This experiment asks you to find the percent KHP in your unknown mixture. Let's work through a sample calculation. So this is a titration using the procedure from the manual. Here the student weighed out 2.0400 grams of the unknown mixture, and the NaOH concentration was 0.1349 molar. They used 10.45 milliliters of that NaOH solution to titrate the KHP, and we want to know what the percent KHP is. Since our unknown mixture was measured in units of mass, we need to compute our pure KHP in units of mass as well in order to make a comparison. So we'll start by just finding the mass of the pure KHP in the titrated sample. I'll start with the volume of NaOH used and convert that to moles using the concentration. I'll use a unit conversion to help cancel out some units, and at this point I'm just left with units of moles NaOH. I'll continue this line of dimensional analysis by using my molar ratio between KHP and NaOH. And finally, I can find grams of KHP by using the molar mass of KHP. All my units cancel out and I'm just left with units of grams KHP. Again, I'm left with many decimal places for my calculator, but I'll analyze the sig figs from my calculation. My initial volume has 4 sig figs. Concentration also had 4 sig figs, which means my result should have 4 sig figs. I'll keep those decimal places for now, as they'll be used in another calculation. Before I compare this mass of KHP to the mass of the unknown, I've got to keep in mind in this procedure, we split up that unknown that we weighed out. What we actually titrated was just that 25 milliliter sample that we pipetted out of the volumetric flask. So I need to find the mass of unknown mixture that made it into that 25 milliliter portion. I'll start with the total mass of the unknown mixture, and that total mass was dissolved in 100 milliliters of solution. If I multiply that out by the 25 milliliter portion I removed for the titration, I get 0.5100 grams of the unknown mixture in that titration. This number has 4 sig figs because the 25.00 milliliters from the volumetric pipette had 4 sig figs. Now I'm ready to compare these two masses to find the percent KHP. The percent KHP is just the mass of the pure KHP divided by the mass of the unknown mixture times 100. If I compute that out, I should get a number with just 4 sig figs. And I get a value of 56.45% KHP in my unknown mixture. This calculation is done for each titration completed, and the average is computed to get a more accurate percent KHP.